This video is to review problems 8 through 10 for Unit 4 test. What are the zeros of the given function? You do not need a calculator to do any of this because you know that zeros is where the function crosses the x-axis, and where it crosses x, remember that's where y equals 0. So this is where the function equals 0. So if the whole function equals 0 and we've got all these factors, then that means that as long as one of the factors, either 2x equals 0, or x plus 3 equals 0, or x minus 7 equals 0, the function will cross the y-axis because it makes the whole thing equal 0. So divide by 2, so here x is 0, negative 3, and 7. So our zeros are 0, negative 3, and 7. Oops. Okay, for B, again, we're looking for zeros. So where does the function equal 0? And the multiplicity doesn't really matter here. So here I'm going to get a fraction, add 1 to both sides, and you have 2x equals 1, so x equals 1/2. For x plus 4 equals 0, x equals negative 4. So my zeros for this problem are 1/2 and negative 4. Okay, I did go ahead and insert a picture of this, but I want to show you, I'm just going to use the picture to confirm what we're going to do without a calculator. So one of the ways that you can find zeros is to look at the factors. Just a while ago we had the factors, but this one is factorable. I noticed that I can use factor by grouping. There's a common factor of x squared, so that would be x minus 2. There's a common factor here of negative 3, so that would be x minus 2. And then completely factored would be x minus 2 times x squared minus 3. Okay, so my factors are x minus 2 times x squared minus 3. Okay, to get my x-intercepts, I need to set each factor equal to 0. So that gives me x is 2, and here I have to take the square root of both sides, and you'll notice that I get plus or minus the square root of 3. And what I want you to look at now is I want you to see how your answers here go along with the picture. Right here, this number, I looked at it, and this value is negative 1.7 something, which is the square root of 3. Okay, here, notice there are two intersections. This first one is 2, 0, so that makes sense, and that's what we have here. That's our rational root, so our rational root is 2. And then this one is positive 1.7 something 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 0. So it is actually the square root of the positive square root of 3, and this one is the negative square root of 3. So both of those are irrational numbers. And there are no imaginaries. So our x-intercepts are negative square root 3, 0, square root 3, 0, and 2, 0. So here are our x-intercepts again, here are our factors, and here's the chart of the nature of our zeros. And then the picture just confirms what we found. we know that we have 4 roots. Okay, so that means we're going to have an x to the 4th when we finish. So if we have rational roots of 1, 1, what that means is when I'm looking at my factors, it means that x minus 1 has a multiplicity of 2 because it occurs 2 times. There are no irrationals, and the imaginaries are x plus 2i and x minus 2i. To get my x-intercepts, those are going to be ordered pairs. Remember, intercepts are always given in pairs. For this one, it would be x minus 1 equals 0, so x equals 1, so that would be 1, 0. For the other one, it would be negative 2i, 0, and 2i, 0. Now, when we multiply this out to get the standard form of our polynomial, the way that I worked this was to multiply this part out first, and that gives me x squared minus 2x plus 1. Remember, use FOIL. And that's really x minus 1 times x minus 1. Then when I multiply these two, it's x squared plus 4. To check me on that, you can do x plus 2i. Just do it in a little box if you want to, and x minus 2i. The tricky part is you're going to end up in this one with negative 4i squared. Remember that I squared is negative 1, and then you've got times the negative 4, and that's where that plus 4 comes in. So then, once you get to this point, you're going to make another box, x squared minus 2x plus 1 times x squared plus 4. So I'll just fill in that. So you end up with x to the 4th minus 2x cubed plus 4x squared minus 8x plus 4. For C, you're given the intercepts, and so from the factors are probably the quickest thing to get. When it's 0, 0, you know that it's really, if you want to think about it this way, x minus 0, and we can rewrite that as just x. So I would write the factors like this. So I know my roots. I can see my roots are all rational. Negative 2, 0, and 2. None, none. To multiply this out, if I multiply x plus 2 times x minus 2, I get x squared minus 4. And then I still need to multiply through by the x, so that gives x cubed minus 4x for my polynomial. For D, you're given the factors. I can see that I've got 2 imaginary roots, and remember that imaginary roots always come in pairs. And then I've got the 2i plus or minus 2i. There are none for irrational and none for rational. My x-intercepts will be now probably the hardest part of this problem is doing the multiplication. So I know in factored form it equals all of this, and so when I'm going to multiply these first, that would give me x squared plus 9, and you can check me out on that using your box method. And when I multiply these, it's x squared plus 4. Then I'm going to use FOIL, multiply those two, and I get x to the 4th plus 13x squared plus 36. So that is my polynomial. And then number 10, if a polynomial with real coefficients has 6, 4i, 3i, and 0 as 4 of its roots, write the polynomial in factored form and state the least degree of the polynomial. Well, for 6, I know the factor at that point is going to be x minus 6. For 4i, remember what I said just one screen back, that if you have 4i, then you know automatically you have the the minus 4i. They always come together. Think about them as best friends. Where you see one, you see the other. And for x, the factor is, or for 0, the factor is just x. So in factored form, I would write this as x times x minus 6, and then my imaginary parts. Aren't you glad you don't have to write it in standard form and multiply it all out? Now, to get my least degree of the polynomial, you look at the multiplicity, and the multiplicity for each one of these factors is 1, and so I just count 1, 2, 3, 4, 5, 6. So it would be 6.